In this video, we're going to work on parts A and B of question 2 on this year's midterm. So the question starts out, we have 5 cups of beverage, and we have 2 coffees and 3 hot chocolates. So you have mom, dad, and 3 kids. So the first question is, what is the probability that the kids choose hot chocolate? Remember, the kids are choosing before the parents. So we write this event. This is P that we get, let's call it chocolate 1 and chocolate 2 and chocolate 3, where I'm using chocolate 1, 2, and 3 to denote the event where the kid 1 chooses chocolate and kid 2 chooses chocolate and kid 3 chooses chocolate. So the way we do this one is we use our multiplication rule. And remember, these events are not independent because the probability, so let's write that over here, they are not independent. So we can't just multiply them out unconditionally. Not independent. Right? So the fact is that this is dependent on this is dependent on this. So they're not independent, so I cannot just write P of, say, chocolate 1 and chocolate 2. It does not just equal the product. So I'll write not the product. CH2. Okay, I got a little smush towards the edge, but so this is not true. Right? So they are not equal to each other. So how do we do this one? Well, we can say the probability, this is actually equal to the probability of CH1 times the probability of chocolate 2 and chocolate 3 given the first one picked chocolate. So that's that first multiplication rule, right? And now we can apply it again to this event over here. So this is equal to the probability that the first one picks it times the probability that the second one picks it given that the first one picks it times the probability that the third one picks it given that the first 2 pick it. Let's erase over here. Just get that guy a little more room. So the probability that the third one picks it given that the second one picked it and the first one picked it. So this guy is going to be 3/4, right? 3/5, sorry. This guy is then 2/4, right? Because we have 2 left out of 4. And this guy is going to be 1/3 because we have 1 left out of 3. So that's 1/10. All right, I can do this because I just applied the multiplication rule once to this guy. All right, I took, this was 1, and then this was the second one. And then we did that, and then we just applied it again to this. So, remember, a lot of people asked me why this wasn't like, oh, I draw something from a deck of cards and I look at the second card. Well, the thing is here, you're actually picking 3 things, but you are looking at all of them. So this equivalent problem would be I draw 2 cards from a deck of cards and I actually look at both of them, not I only look at the second one. So now we will do part B of this problem. What is the probability that exactly 1 parent gets coffee? So we'll rewrite this as the probability that two kids get chocolate, right? Because that way, by the time we're at the parents, I'll just erase that. By the time we're at the parents, then what happens is there's only two left, so one of them has to get it. So get chocolate. To do this, well, we have several possibilities, right? We could have chocolate, so chocolate, coffee, chocolate, coffee, chocolate, 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 coffee, and coffee, chocolate, chocolate. And we can just add up each of these probabilities. So the probability of this guy is 3/5 times 2/4 times 2/3, right, because there's two left at the end. The probability of this guy, which is, so this guy works out to be, let's see, that cancels with that, and that 2 cancel with that, so this guy is going to be 1/5. So this guy is 3/5 times 2/4 again, but then here this is going to be times 2/3 because there's two of these left at the end, so that's also 1/5. And the probability of this guy starts off with 2/5, and then he's taken one away, so now it's 3/4, and then it's 2/3, and that's also a 1/5. So we just add these up, add them up, right? Why can we add them up? Because these are they're disjoint events, they're mutually exclusive events, so I can add them up. And if the exactly one parent gets coffee, then one of these sequences must have happened because we had to take two of the hot chocolates. So add them up, mutually exclusive, and we get 3/5. So that is 3/5. So that is our final answer. Stick around for part C and D in the next video.